Beside that, dear colleagues, I would like to talk about AI in metallography, the integration of AI in metallography and quantitative image analysis. Basically, it's to explain the background why I'm doing that. Basically, this is a beginning step of a longer process. So basically, what we have now, we have the metallography itself as science. We have the quantitative image analysis with different microscopes, different way of method of measurement, image analysis method, softwares, and basically final results. So that two together made a knowledge and experience-based failure detection method in any kind of metallurgical task we can solve. And that's when the AI integration comes into the picture, because by supporting the failure detection and making it better to or make the complex things together to make the decision making easier, that will generate a sustainable knowledge base that we can use in the future. It's basically not just one person's knowledge. It was summarized a lot of different sources together. What kind of learning methods that we can use in this case of problem? Basically, there are several learning methods. I just want to highlight three of them. The first one is the deep learning for image segmentation, which can be the UNet, the DeepLab V3, MuskR, CNN are commonly used for segmenting different regions in micrograph like grains, phases, or defects. Then we can use the convolutional networks. Those are basically for classification task to identify material types, defects, or phase boundaries based on image features. But the first that we will use, or we can use as a first step or an initial step to build up this total complex structure, that's the transfer learning. Basically, that's what we are doing in the university. We are trying to teach our students, but usually they are not checking the lectures. Instead of that, they are using their smartphones. That's the difference between the AI. It won't use the smartphone and it will follow the regulations. Use protein models and like ResNet we can use, or VGG, on general images datasets, then fine-tune them for metallographic analysis. So basically we have several microscopic images that we can collect together, more than 50,000. So basically that will gives the base for this kind of learning method. So if we finally reach that point that we can select the learning method, and that will be the transfer learning strategy, it can be the base of the continue. So basically the step one will choose the protein model. Then the step two is the fine tuning and the model and micro metallographic datasets. And then train the modified model on the labeled metallographic images. And of course, we have to have a scientific background and a scientific foundation for this kind of topics. As you can see at the left side, basically comes from my work. We have microscopic images, tons of them. We have identified failures, pictures of them, case studies, and so on. And basically, I'm also teaching the fracture mechanics at the university, so I have several examples of different problems and their solution that I collect together. So I also have a database. And then there are corrosion case studies. It also comes from my experience. And beside that, at the last 10 years, I'm using the finite element method softwares as well. Basically, I also use the ANSYS. It's a very popular one, I think, so in finite element analysis. And then those are the background at the moment. Then these quantitative analysis in the metallography can come from case studies, knowledge base, corrosion, and fatigue, and other problems. And then the integration. Basically, we will use the transfer learning. We can use this method because we have recorded image, not online image. So we don't have to make the decision or instruct the AI to make decision by live image, it will be easier. So for that, we can use the transfer learning. As I adapted some figures at the right side, those are from an article when they are continuously monitored a 3D printer by the resonation, and they try to determine the problems of the printing by applying artificial intelligence. And the data management method, basically, we have the data connection now, obtain the microscope images for perfect detection. We need to pre-process them, then the data processing and the data labeling. That will be the last step. And then how can we increase the solution accuracy and the accuracy? Basically, we can use the IOU method. It's intersects over union, the dice coefficient, accuracy matrix. And there are a lot of challenges in this problem, just like the class imbalance, overfitting, and interpretability. That's a long word for me. And beside that, if we can solve these problems, or if we can comply in these kind of challenges, basically we won. So we can have the final result. So the possible workflow can look like as the metallographical and quantitative image analysis process will gives you the optimization and pre-processing of information. Then by using our supercomputer that we are lucky that we have one in University of Debrecen, we can use the artificial intelligence transfer learning method for data analysis and data labeling. And from the result, we will have the accuracy matrix, and there is a possibility of selection. So basically, it will be just a background help or something for the decision making at the moment, but then it can become complex solution, basically. So it can generate a complex solution, and you can decide if you use it or not. And after the future possibilities of this project, if it will be successful, hopefully it will be, then I can integrate it in fracture mechanics, non-destructive testing and evaluation. It's extremely important nowadays because we have to compare the two results together. And then the FEM simulation to show the results in a more popular form. And then last but not least, I hope I keep the time limit, a review of a real industrial application which is existing now for alumina casting. The first cycle is the slurry preparation process, then the casting parameter control process optimization, and then quality validation process and vision inspection of the system. So basically, this one is a working study. In the article, which will be published, you can read more about this kind of information that I showed on this slide. So thank you for your kind attention, and those are the references. And if you want, I'm open for discussion later and cooperative projects as well.